A first good use case for this pattern is when you have a need to add responsibilities to individual objects dynamically, without affecting other objects. The example we just covered was thus a good use case. Another good use case for this pattern is when you need to be able to withdraw responsibilities you attached to an object. Decorators can be applied dynamically, and thus also removed dynamically. That's an advantage when, for example, you want to switch out storing mail messages in a database to another user store. Simply remove the message database decorator and, if needed, replace it. Lastly, you can use this pattern when extension by subclassing is impractical or impossible. For example, when the class is sealed. Let's have a look at the pattern consequences. The first consequence of this pattern is that it is more flexible than using static inheritance via subclassing. Responsibilities can be added and removed at runtime ad hoc when needed. If you compare that to subclassing, which leads to increased complexity of your system when many different behaviors must be added, the decorator pattern is definitely preferable. 2. It avoids feature-loaded classes that don't respect the single responsibility principle. With this pattern, you can split that class up until there's just one responsibility per class, thus adhering to the single responsibility principle from the solid coding principles. And 3. This pattern does tend to litter your system with lots of small simple classes. That's a disadvantage that potentially increases the effort required to learn and debug the system. Let's cover the related patterns next. As usual, a few patterns are related to the decorator pattern. From the family of structural patterns, there's a relation to the adapter pattern, but the adapter pattern gives a completely new interface to an object, while the decorator pattern only changes its responsibilities. Another related structural pattern is the composite pattern. A decorator can be viewed as a composite with only one component. That being said, the decorator isn't intended for object aggregation, while the composite pattern is. Lastly, a behavioral pattern, the strategy pattern. While the decorator pattern lets you change the skin, which is the outer side, of an object, the strategy pattern lets you change the inner workings. So, both allow you to change an object, but in a different way. Time for the module summary. The intent of the decorator pattern is to attach additional responsibilities to an object dynamically. We implemented this pattern to add functionality like collecting statistics and storing sent messages to 2 mail service implementations. The pattern offers more flexibility than static inheritance through subclassing. Up next is the composite pattern, one that's related to the decorator pattern.